Hello, this is Keith Kolod, Post-Production Supervisor at Virtual, and today I'm going to be going over my personal workflow for stitching VR footage using Nuke and Cara. This is going to be an easy-to-follow tutorial that will take you from beginning a VR stitching project through completion. And knowing that this may be the first time you're using Nuke for some of you, I will also be going over the basic knowledge of Nuke that you'll need to get up and running. So let's get started. The first step would be to bring in footage, and that's a node called the read node, which you can click on and then go and navigate to your footage and bring it in one by one. But the easiest way to do this is to just drag them in. So these are all our MOV files for each of the 9 cameras, and we're going to drag them in. If I select all of these and hit L, that is going to auto-align them. And I can see that they came in at the wrong order because I brought them in based on file size. So we're just going to reorder these from left to right as 1, 2, 3, 4, 5, 6, 7, 8, and 9. So now that I've done that, let's go ahead and take a look at our footage that we've brought in and set our project settings. You should have a viewer node already in your node graph by default, but if you don't, you can create one just by clicking on any footage that you want to look at and hit 1. That is going to create your viewer node. It is also going to set your one pipe to that viewer node. The viewer node can have up to, I believe, 10 views attached to it. So if we click on the new footage and hit 2, and the new footage and hit 3, you can see we've got pipes 1, 2, and 3. And if I click up here in the viewers tab and I actually hit on my keyboard 1, 2, and 3, I can toggle between all of those views. At this point, I like to set up my project settings. In order to do that, you can click anywhere in here in the node graph and hit S on your keyboard. It's going to bring up your properties panel over here on the right. In here, you can set things like your frame range to work within, your frames per second, and the actual format size or resolution size that you're going to be working within for your project. If I want to see how many frames I have to work with as far as the footage is concerned, I can double click on any one of these read nodes down here, and in the properties panel it'll bring up what the frame range is. So you can see that each camera I have over 11,000 frames to work with. So back into our project settings, I've set the frame range that I'm going to be working with, which is frame 9250 to frame 9550. The frames per second I've set to 30 because that's what we shot with our individual cameras. Most VR projects are going to be 4096 by 2048, so I've set that to 4K lat long. A lat long has to be a 2:1 ratio, or VR will typically not work in any VR player. And last, when it comes to the read node, we're going to need to set the offsets for each camera. This is because we're working with VR footage, and the cameras don't necessarily all start and stop at the exact same time when you hit the recorder. They might be off by a couple frames. So you can counteract that by coming into the frame section of the read node, clicking on that and hitting offset. And if you know your sync data information, you can click that in here. I happen to have that information, which I've gotten from lining up the waveforms in Adobe Premiere and using that information to fill in the offsets. So I will do that now. So you can see now as I double click through the read nodes up here in the offset section, you'll see the individual numbers of offset 2 frames, 2 frames, 1 frame, 1 frame, 1 frame, 0, 1, 1, and 0. This is to get the actual frames to line up so that when we stitch it together, it all seams together correctly. There's a wealth of information and tutorials out there for Nuke, and I urge you to go through those to get a little further up to speed. But for now, we're going to start hopping over to the VR building of this script and actually stitching things together. So let's pull up Cara's camera solver node. That can be done by either clicking in the node graph and hitting tab and typing in C underscore, and it'll bring up all of the Cara nodes, and we can click on camera solver here, or we can go up in here to the toolbar and click on the Cara button and grab the camera solver that way. The camera solver starts off with a one pipe, and I typically just plug these into the corresponding cameras, but with stereo we're going to do things a little differently. We're going to plug into each other camera because those are the left eyes of the stereo pair. And just to reiterate, there's nothing in this workflow process that can't be done in a single mono format. We just happen to be using a native stereo camera rig. So let's start by plugging the one pipe into the one camera, dragging out another pipe from here to the left, which will grab our two pipe. We'll plug that actually into camera 3, and we're going to be doing this for all the odd cameras. So there's pipe 3, pipe 4, and pipe 5. Our stereo stitch is going to be made up of 5 cameras for the left eye and the opposite 5 cameras, with the exception of camera 9 because that is in both left and right eye because it is a mono camera. That will be set up for the right eye. So from here, Cara is great at doing things automatically, but the more information you have to give it, the better. For instance, if you know the focal length of your camera and the actual film backing, or the individual camera that you used, maybe in one of these presets, it would be good to set that up now. But since we're working with a custom rig, we're going to go with the workflow that maybe you don't have all that information, so we're going to work with the automatic tools. So now we're going to go into the cameras tab under the camera solver. There's a lot of information you can put in here. First thing we're going to do is get it roughly into the sizing and focal length that we want. So if we look through the camera solver, we can see by default that the image is really tiny of all these cameras, and we know that we're going to end up filling up this entire lat long with these 5 cameras. So the lower you drop your focal length, the larger those images are going to get. If I select all of the cameras, I happen to know that the cameras that we roughly use were set to around 7.5 focal length, so I'm just going to type that in, and that's just going to get us roughly into the area that we're looking for. From here, we're going to want to set up our mask. Now our mask we know isn't rectangular because with the original footage it was a circular lens. It looks like it's fisheye. So we're going to set that to elliptical, and that's going to change the actual sizing of our mask. In here with the actual size, we can slide this down until we get it to roughly the area that we want, but we do want to cut off some of the image. As you can see around here, this is the edges of the lens and a little bit of the rigging, and we would like to cut that out. So we're going to slide this down to about 0.4. So I can slide it, or I can just go in and type these in individually. And if I hit the alpha channel, it will show the alpha. You can see the feathering that's on that. You can change and slide that around using this feather slider, but we're going to keep that at default at 0.4 for now. And you can toggle back from the alpha to the RGB by hitting A again in your viewer. So let's hop back on over to the camera solver tab, and in here you're going to want to make sure you're on your first frame and that is the frame that has its first analysis key on it. You can set multiple keys in the camera solver tab, but I typically don't in my workflow. Next we're going to look at this analysis section. This is where we're going to want to tell Cara how to handle figuring this stitch out. So under the focal length, we roughly knew what focal length it was, but we don't know for sure. So we're going to change it. We're going to keep it on optimized single. If we knew what it was for certain, we could set it to known focal length. Under lens distortion, again, since we don't know exactly what it is or what lens was used, we're going to change this to optimized single as well, because we're going to assume that all of the cameras are using the same lens distortion. We just don't know what it is. Under camera layout, there's spherical layout and nodal layout. We know that this was shot as a spherical camera rig. Nodal would be if it was shot with one camera, slid all the way back to where there was no parallax change, and rotated around that center pivot point. We know that this was set up with an actual camera rig that was in a spherical layout, so we're going to keep it on that. And from here, we're going to hit match. Here you're going to see all these lines pop up, and what that is it's actually a point to another point from camera to camera. These are how it's actually solving it and finding pixel to pixel between the multiple cameras and then going to solve and stitch it all together. So now we can hit solve, and it's telling us right now there are not enough valid matches for camera 5. So we know we're going to have to fix that one camera manually. Let's go ahead and hit OK. And we have a rough stitch of our entire shot, but you can see it's completely at the wrong orientation. So we can come over here to our actual Cara tools, and we have a horizon tool, a camera tool, and a matches tool. we're going to grab the horizon tool, come over here and hold down Control and Alt, click and drag your footage around. We can actually reorientate our shot doing it this way, and the reason it came out incorrect originally was because if we look at the individual cameras, they're all set up sideways. So that's why it came out with that result. So no big deal, we can just slide it around. Let's get this guy into the center. Again, holding Control and Alt and dragging your footage around. This is our camera 5 that it didn't solve correctly for, but we're going to do that manually. So go under the Cameras tab, and you can see under camera 5, it doesn't have any information that the other cameras have. But it doesn't mean we can't use some of that information. If we go to camera 4, it has the right focal length, but camera 5 doesn't. All the other focal lengths are going to match. So we want to make sure that that camera 5 has the same information as far as focal length and distortion as these other cameras do. So we can just go to camera 4 and we can copy these values, and we can go to camera 5 and we can paste those values. We're going to do the exact same thing for the distortion on all 3 tabs. Grab the third field, copy, and paste. At least this way, the camera now has all the same distortion values and focal length, and now we just have to slide it around and actually give it its pivot. So now we're going to adjust and slide that individual camera around by selecting it and coming over here and selecting this little camera button. That's going to allow us to slide our individual cameras around or adjust them as needed. So for here, we're going to again select Control and Alt, click and drag our footage around. Now as far as lining things up goes, we're going to find some features that we're going to try to line up manually. And in order to do that, you're just going to want to analyze your footage, and I can kind of see here that this plant coming up here outside the horizon is this plant continuing. So I can click and drag this camera over here to roughly get this to match up into place. The stitcher node is going to line things up a little better for us, but for now this is probably going to be a good enough result. And at this point, again, feel free to go in here and at any point grab your horizon tool and readjust things as needed. It's one of the beauties of working in a nonlinear program like Nuke is that at any point you can go back to your beginning processes and adjust things, and it'll continue on down the tree with those results. For some projects, this result might be good enough, and is typically considered a quick stitch. You could just write out of this camera solver node and be done with the project. But we're going to take it a step further and go into the fine stitch process where we can actually clean up the image a lot further. From here, I like to throw in a split and join. What that is it's going to give us the ability to adjust individual cameras as needed. So if we select the camera solver and hit tab, we can start to type in split and join, and we see it right here. As we click on that, it gives us all of our individual cameras. You have to keep your main camera or your left and right eye camera if you're working in stereo. But then here are the individual cameras, cameras 1, 2, 3, 4, and 5. If we click on them, we would expect to see just that individual camera. In order to see that, you must make sure that under the camera solver you have your camera projection set to lat long. By default it is set to pass through, and it will not look that you are expecting. From here, any process can be done individually on these cameras through these pipes. You can attach rotopaint nodes or grade nodes or grid warp nodes. We're going to actually adjust the camera 5's color, so that's where we'll actually put a grade node. The reason we're doing this is if you look at the overall result, we exposed down for the sky on this top camera, so you can see where it lines up with the ocean. It's too dark compared to the rest of the cameras. So we can fix that by putting in a grade node right after camera 5. You can either select the camera 5 node, hit tab, start to type in grade, and bring it in there, and it'll automatically put it in the pipe. Or you can do the same thing, bring the pipe off to the side, and plug that in later. So let's go ahead and zoom in on our color here, and we're going to start to adjust our values. We're going to want to take off black clamp. We typically don't want to clamp our values unless necessary. And we're going to adjust our gamma. Let's go ahead and bump that up a little bit and bump up the gain. Now we're not seeing a result And that's because it's still just dragging from the left and right eye views into the join view. That's what we're viewing. In order to see the actual process of all these cameras restitched back together with our fixes, we're going to want to use something called the C Blender node. Grab that and plug that into your join views. You can render out of here, but I'm typically going to be using it just for viewing purposes before we get into the Stitcher node. So if we look at that now, you can see that our camera gets brighter. Let's go ahead and up it a little bit further with a little bit more gain. And this is already starting to look a lot better. If I select the grade node and hit the D button on my keyboard, that disables the node. You can do this with any node throughout the process if you want to toggle on and off your work to see the results. This is toggled off, this is toggled on. Again, just hitting D on your keyboard. Now onto the Stitcher node. If you asked me what was the node, the reason that I like to use Cara over any other VR package, this is the reason. We're going to zoom in on these plants a little bit here because this is where you're really going to see the magic work. So now I'm going to come down into my node tree and I'm going to attach a Stitcher node to this join view. Go ahead and hit tab and go ahead and find it with C_Stitcher, or go into this button and find C Stitcher. When we plug that in, we're going to make sure that it's grabbing all the 5 cameras. Now, these cameras, if you hit S and go to the Views tab in your project settings, these 5 cameras were generated within the camera solver when we plugged in those 5 pipes. The left and right eye is set up because I'm working in a native stereo project. If you're working in a mono project, yours will probably just say main. If you want to be working in a native stereo project or setting it up for stereo, you can click Set Up for Stereo here. From here, let's see what this node does by default. We're currently viewing the C Blender, and that's just using the alpha channels to ghost the images on top of each other. But we want to actually have Cara figure out where patterns of pixels are replicating and warp those together so that it seams up better. By default, here's what that looks like. It might not look like much, but when you toggle between the two, look at how much work is being done. In other VR packaging programs, this would have to be done manually with grid warps. But right here, you can see this plant and this plant in particular. When we toggle between the two, it's warping those together automatically. Cara has found those pixels in repeating patterns between the cameras, warped them, and put them on top of each other. The reason that those plants don't seam up as well as the background does initially is because they're closer to the camera. The parallax between the two cameras is greater as an object gets closer to the lens. That's why everything in the background matches up automatically, and everything as it gets closer to the foreground, especially when it crosses over the seams of the cameras, has to have a little extra warping to get into place. Now that's how good things get with just the settings at default. But we can go into the Stitcher node now and go into our Vectors tab and really start to dial these things in. For one, we want to switch it from default source to lat long because that's what we had switched our camera solver to. And then we're going to go into the Vectors tab and we're going to adjust the vector detail strength, consistency, iterations, and warps. Each of these things, as you dial them up, will increase the load time of the image. But for this shot, we actually have a lot of levels of detail. So we are going to have to increase it a bit. Your shot may not need that. So let's dial some of these up. I'm going to take the vector detail to about 0.6. The iterations to about 12. And the warps, think of it as kind of like a grid warp. The 4 kind of gives it 4 corners of each camera to kind of warp together. But we have a lot of levels of detail here, so we want to increase that up quite a bit. We'll go to about 10. And the strength is how strong it's going to actually try to stretch these pixels together and when it's going to kind of give up. We're going to increase that to 1.5. And consistency is how much it is going to stay consistent between how far it moves each camera. So we're going to go ahead and increase that to about 4. Each one of these things completely changes the math that's being done and the result that you're going to get. So go ahead and slide these things around and take a look at the different outcomes. Also, you can duplicate the C-stitcher and plug that in and change the values of one of them and toggle between the two with 1 and 2 on your viewer. That's sometimes the best way, just due to the load times of the stitcher node. But either way, play around with it a little bit, see what's getting you the best results. This is where I like to start copying over my work into the right eye and start looking at it in stereo. That does not mean using the stereo tab in the stitcher node. That tab is reserved specifically for generating stereo out of the parallax in a mono camera rig setup. It will take the parallax between one camera to another camera and try to generate stereo out of that. Since we have a native camera stereo pair setup, we can avoid that tab and do this manually. Because of the way we have this set up, this is pretty simple. Go ahead and zoom out of this image a little bit so you can see the offsets between the two. I'm just going to come in here and copy this entire tree down here. Control C and Control V. That leaves me with the one pipe. I just have to plug in this one pipe and the pipes after that to the even cameras now. So there's camera 1, camera 2, camera 3, camera 4, and the only odd camera is camera 9 because that is a mono camera setup. If I go into the camera solver and drop down into the cameras tab, just want to make sure that all the same values are there that are in the left eye version, which they should be. And from here, we actually have a left and right eye camera now. So if I look in the left eye stitcher and then go to the right eye stitcher and toggle between the two, you can see we have a left and right eye. Now, you'll notice if you're used to stereo, you'll see some vertical misalignment problems. We're going to fix that next. I'm going to delete this other viewer because it's not needed. And I'm going to generate a node called Join Views. And if you have your cameras set up for stereo, you should have a left eye and a right eye. I'm going to plug the left eye pipe into this stitcher, the right eye pipe into this stitcher. Now when we view this node, instead of actually having to toggle with a 1 and 2 between the two cameras, if I actually swipe from left to right eyes using these buttons up here, I can toggle between the cameras that way. You need to do this in order to use the disparity generator. So let's grab that. We'll go into Cara, come down to C_disparity generator, and the disparity generator is going to analyze the pixels and the movement differences between the left and right eye. We can then use that disparity map in an iDistort to fix the vertical misalignment. Make sure under projection you change it from default to lat long, just as though we've done in the stitcher and in the camera solver. And from here, we can go in and look at our new disparity map that we've generated. Now, it might be a little hard to look at, but this is actually the value information that differs between the left and right eye. Switch back to the RGBA. From here, we're going to shuffle copy that channel, the disparity channel, into the right eye. So in order to do that, hit Tab and grab a shuffle copy node. We're going to plug the 2 pipe into the bottom of the right stitcher and the 1 pipe into the disparity generator. From here, it's set up to shuffle in RGBA channels from 1 pipe to 2 pipe, but we're shuffling in a disparity channel. So we're going to switch the 2 pipe to disparity, and we're going to switch the 1 pipe to disparity. And we're going to say we want all of the channels, the XY, from disparity pipe 1, and put them into the disparity pipe 2, which is the right eye. The shuffle copy may take a little bit of getting used to. It's a little different from other programs that you're used to working in, but once you get used to channels, this will completely make sense. If we follow this line, it hits this box and continues on to this outcome. Same from here, this input Y goes to this output Y. If you follow these down, that's how that works. Kind of just follow the flow of pipes. Before moving on to the next step, I wanted to go over the iDistort node in a little more detail. The undesirables node, in its simplest terms, pushes pixels around based off of a map that you feed it. And let's go through these options here. The channels is the image that you're actually feeding the undesirables. So that's going to be this pipe, wherever you plug it in. If you plug it in here, it's going to have all the channels that come through this pipe to be fed through the undesirables. However, you can change it to individual channels if you'd like to do that. The UV channel section is where you're going to actually feed the map that has values that tells where to push those pixels to. This could be a ST map or a disparity map or even just an alpha channel. As long as the actual map that you're feeding into it that you place in that UV channel section has values, you can see as I scroll over this, these values are changing down here at the bottom here. It can use any of those values depending on whatever map you feed into this UV channel section. We're going to be using the disparity channel, and we'll use that later. The UV offset is a pixel offset, and UV scale is kind of the same thing, but scales the image and multiplies it based off of this value. This is going to multiply whatever value you place in. So if the value in the map is 10, then it's going to move a pixel 10 pixels. But it'll do it uniformly. It'll do it in X and Y. If you would like to do it ununiformly, you can click this little 2 here, and that'll bring up the width and height. Width is going to be moving the pixels based on the value that you feed it to the left and right, and height is going to be moving the pixel vertically. So now let's use the undesirables to fix that vertical misalignment problem. So if I plug that in here, and we view the undesirables, we want to make sure that we're affecting all channels but using the disparity channel. So now we're going to go under the UV channels tab, open that up, and hit disparity. Now we only want to fix the vertical problems. We don't want to fix the left and right problems because that's what's giving us stereo. So we're going to hit this 2 over here, and we're not going to fix width at all. We're going to set that to 0, and we're only going to fix height. So if we toggle that on and off now, you can see the warping that's happening right here. This should be warping up to roughly align with the left eye. So if I toggle that back and forth, you'll see that we actually went in the wrong direction. If I toggle these back and forth, we've actually caused more vertical misalignment. That's a simple fix. Just go into the height and type in -1 instead of +1. +1 would be if we were trying to fix the left eye to the right eye. Now if we toggle between the two, that vertical misalignment problem is virtually taken care of across the entire lat long, and this is going to make viewing the stereo a lot nicer and not give you so much of a headache. Again, this entire step, this entire tree, and this entire vertical misalignment fix is only for if you're working in stereo. Otherwise, you just have this tree right here. Now I'd like to quickly garbage out the rigging that's still visible in my lat long, and that's in camera 3, which is causing the issue. So we'll hit tab, grab a roto, plug that into the 3 pipe, quickly roto out the area that's causing the issue, and that's going to be this piece of rigging that we do not want to be visible anymore in our lat long, and it will use the other cameras to compensate and fill in that space. I'm dragging out the feather points by holding down Control and clicking and dragging out the points to cause some feathering from here to here. And then if we double click on the color and drop the alpha channel down to 0, that is going to punch out a hole through the alpha channel. So now, if I go to the alpha channel and look at this section, you'll see that there's a black section here which is not going to be used. Previously, it looked like this. So now we're telling Cara not to use this section. And when we go and look at the result and come back into RGBA, you'll see that that section's been removed. So now if I toggle back and forth between having the roto on and having the roto off, you can see that Cara is now no longer using the rigging piece from that original camera in our lat long, and it's compensating and using the other cameras to fill that space. And we're just going to copy and paste that roto over into the right eye camera 3 as well, which you will not be doing if you're working in mono. Now we need to move on to stabilizing our final result. The scuba diver is swimming through a free space, which looks great with the camera, but it's going to cause some rolling issues. When the camera rolls back and forth like this, it can cause your audience to get a little nauseated. So we're going to try to reduce that with stabilizing the footage. So now we're going to grab a Cara tracker node. And the reason we use a Cara tracker node is, for one, it's going to help us fix that pan, tilt, and roll problem. But also, if a tracking point goes off the edge of the screen, it will continue to track on the other side of the lat long. So we're going to grab this tracker and we're going to plug it into the left eye. We're not going to plug it into further down our script, because down here there's a lot of warping that's going on from the stitcher in order to get things to line up, and we want to start tracking the pre-warped footage. Now, I've already tracked this footage before, so I know roughly what spots to track. I just hit a add track button right here, and it gives me a tracker, and I'm just going to go ahead and put that over this plant over here. And I'm looking for something that stays within view, that's roughly in the horizon and in the background, that doesn't have its own movement to it, other than the scuba diver swimming through the space, and that we're going to have to counteract later. Then we'll grab another track and place that also into an area on the background. If I set the second tracker to roll, you see that we get 58 degrees. We're looking for something around 90 degrees. So I'm going to actually find another point, and I'll probably track something over here on this side of the screen. 114 is okay, and it will change throughout, but that'll be alright. The next step is to have both tracks selected. Come up here where there's a little arrow and R, and that's going to track forward throughout the entire frame range. Go ahead and type in the frame range that you want. It should by default go to whatever your global settings are in your project settings, and hit OK. This is going to be a long process, so I will pause it now and come back later. Now that the track's done, we're going to go kick out a transform that has that data built into it to stabilize the footage. So under transform, I'm going to select the reference frame that I want to set as my first frame. Just be on the frame that you want to be on, and then hit set to current frame. Make sure it's set to stabilize. Select both trackers. Come down to export, say spherical transform, export stabilize, create. And that's going to generate a stabilized track. If you look at that track and then go throughout the shot will be stabilized. However, since he's moving throughout space, it's going to rotate around a little bit. And we're going to counteract that with another spherical transform. So let's go ahead and reattach that now to our final output. Our final output in stereo is going to be these two eyes together. If it was mono, it would just be this eye. So I'm going to create a join views and join my left and right eye together, and this is going to be my output. So I'll take my spherical transform that was generated by the tracker and plug that into the bottom. We'll take a look at that result, and we're going to now offset the image for counteracting the fact that he's moving through space and that everything we were tracking was actually moving. So go ahead and grab a Cara spherical transform and plug that into the bottom of the tree. We're going to want to key the first frame because we know that we don't want that to change at all. We know the first frame's good. That's where we started our track. So let's go to the last frame, and we want to kind of keep this guy in the center of the screen. We're going to rotate him back into place. So we're going to use the X value here, and we're going to put him roughly back into space there. But now you can see the horizon's all bent, and it wasn't that way on the first frame. If we go to the first frame, it's a little straighter. So we go back to the last frame, and now we're going to want to adjust some of these other values. Takes a little tweaking, but we're just trying to minimize the amount of change from the first frame to the last frame. We know it's going to be moving around a little bit because he's actually swimming in free space, but this will help counteract anybody getting nauseous. Now that we've done the first frame and the last frame, let's go to the middle frame, see if our keys hold up. And you can see that they actually hold up pretty well. So I'm pretty happy with this, and just in 2 keys we were able to fix the fact that we were tracking something that was moving throughout space. The last step is rendering. So go ahead and hit tab and grab yourself a write node. Plug that into the bottom of the tree. I also like to throw a reformat on right before I render, just in case there's anything outside the bounding box and we want to trim that off. And inside the write node we have all these individual cameras. Well, we don't need to render those out. So we're actually going to go into the Cara VR tab, set it to stereo, and hit set. You might set it to main if you're working in a mono project. And in here I'm going to quickly copy and paste my tutorial name and find a directory where I would like to save this. I'll just go ahead and save this inside comp, inside a new folder that says test, and inside there plug in my name. Then I'm going to underscore %v because I'm rendering out multiple views. I'm rendering out the left and the right eye. You would just skip that part. Dot %05d dot exr because I'm going to render out exrs, and I would like it to have 5 frame padding. That's what this %05d stands for. Go ahead and hit save, and it's going to bring up my settings. I'm going to leave all this default, and the next step would just be hitting render. You'd select render, you'd select the frame range that you want to render in. I would go to global because I already have that set, and I would hit render. And with that, you've completed your VR stitch. In conclusion, we'll go over the steps real quick. I have 9 cameras set up here. This workflow works with any camera rig setup, whether it's mono or stereo. I have a left and right eye pair for each, except for the top camera, which is mono. You will probably just have 1 camera for each, or if you're using native stereo, you might have a setup like this. Then you are setting up your project settings and going into the camera solver. The camera solver is what you're using to get things into place, the individual cameras lined up, and a lot of that is being done in here. And for when a camera messes up, you'll be able to rotate that into place and then reorientate it with the horizon tool. Then you're doing a split and join. The split and join allows you to adjust individual cameras like we did with the color here, or rotoing out that piece of rigging that we didn't like. From there, to see those results, you use a C blender, but the C Stitcher will also give you those results. So the only reason to use a C blender is for when you haven't set up your C Stitcher yet. The C Stitcher tool is what's going to give you all of that warping into place from the individual cameras. It's really what does a lot of work in Cara for you. We can see here when we toggle it on and off that all of these plants warp into place, and that's a really important tool for us. From there, we either in stereo fix the vertical misalignment problems with this section here, and then after that you use the Cara tracker tool to build yourself a tracking system that can fix the stabilizing issues so that people don't get nauseous when they're in a VR space. And from there, you write it out. Thanks for watching this tutorial. I hope this makes it a little easier for you to get from beginning to the end of your VR project. And once again, I'm Keith Collard from Virtual, signing off.